What's good, YouTube? It's Alma with the sauce, and this right here is part 2, where I talk about how to come up with a formula to partition a line segment in a particular ratio. Before we get into this, I want to be clear about what I mean by partitioning a line segment. All right, so what we're trying to do is we're trying to figure out where point B is, such that what we call partitions or splits segment AC in a 3:5 ratio. Let me explain it like this. From A to C is split up into some equally spaced amount of parts. And we're trying to find point B such that the number of parts from A to B is 3 parts. And then the number of parts from B to C is 5 parts. So in total, there's 8 evenly spaced parts. Basically, what we can say is, if we know that AC is 8 total parts, well, 3 of those 8 parts is going to be between A and B. So 1, 2, 3. There's where point B is. Now, if you notice, from A to B is how many spaces? 1, 2, 3. And then from B to C is how many spaces? 1, 2, 3, 4, 5. So that's what they mean when they say partition it in a 3:5 ratio. So if we're looking at it as a fraction, then the distance from A to B is not 3/5 of AC, but it's 3 out of 8 spaces from A to C. So there's 3 spaces from A to B, and then 5 spaces from B to C. So there's 8 spaces total, which is 3 plus 5. So basically, the way you need to think about it is that AB equals 3 over 3 plus 5. Remember, that's where that 8 came from. 3/8 of AC. So if you can understand that AB is just a fraction of AC, then that's basically what partitioning a line segment is. So we can use this to show us how to derive the formula to find a point. All right, now, so for the rest of the video, I'm just going to show you how to figure out the coordinates of point P that partition any segment AB into A to B ratio. So basically what we have to do is we have to use our ratio that we're given and the fact that we can create similar triangles to help us figure out that point. And so the first thing I'm going to do is, from our segment AB, we can make a right triangle by going straight to the right and then straight up. And then, this will be a 90-degree angle, so that'll make a right triangle. And then wherever point P is, if I go straight down and make a perpendicular with that side, then I have another right triangle. So at this point, I just created a smaller right triangle and a bigger right triangle. And it turns out that both of those triangles are similar because they have a pair of corresponding angles and they're congruent. And then again, angle A is common to both triangles, so it's congruent to itself. And so angle similarity is why these two triangles are similar. And so what helps a lot of students is, if they have a configuration like this, what I like to tell them to do is to separate it into 2 separate triangles so you can really see what they're looking like. All right, so what I went ahead and did is I basically took my smaller right triangle and separated it. And so what I'm gonna do is I'm gonna call this point right here, I'll call that D. And then so that'll make that point D. And now the proportion, or the ratio, that I want you to see is this side right here is like the smaller of the 2 sides, and that's length A. And now the bigger of the 2 sides is, a lot of people want to say it's B, but it's this entire length of this side, which is actually A plus B. So the ratio is little over big equals little over big. And so what we can say is, we can say that A, which is the little, over the big, which is A plus B. We can say that because these 2 triangles are similar, we can say that this little over this big is equal to that ratio. And then this little over this big is also equal to that same ratio. So I can say my little, which is PD, over the corresponding big side, which is BC. And then I can also say that's equal to this little rather, which is AD, over its corresponding big side, which is AC. And the reason I know this relationship is true is because these two triangles are similar. And that's what it means for triangles to be similar. All of their corresponding sides are proportional. And so that's going to come in handy when trying to figure out the coordinates of this point P. So in order to find the coordinates of P, we can think of it as starting at point A and then going over a distance of AD and then up a distance of PD. And so if we can figure out this distance and this distance, then that can help us find that point. And so what I'm going to do is just use the relation that we know to solve for both AD and for PD. And so I'll just use this right here to solve for PD first. So since we know this relationship is true, we can go ahead and cross multiply and try to get PD by itself. So that'll leave me with PD times A plus B. And then that's going to be equal to A times BC. All I'm doing is cross multiplying. All right, so now these A plus B's are going to cancel out. So that leaves me with PD equals, and then the way I want to write it, since I want you to see this ratio, is to have A over A plus B. So that's that ratio that I'm talking about, times BC. So that gives me the distance from here to here. And so now all I need to find is AD, and then that'll help me get my coordinates. All right, so now we got to find AD, but we can use that same relationship from earlier to give us something to cross multiply. So basically, since these two are equal, I'm just going to write them next to each other. AD over AC equals A over A plus B. And so I can cross multiply. This time I'm trying to find AD. So that'll leave me with AD times A plus B. That's going to be equal to A times AC. And so now all I have to do is divide again by A plus B on both sides. And then that'll give me AD by itself, which is what I want. So now that those A plus B's are gone, I can say AD equals, again, that same ratio, A over A plus B times AC. So now I have the distances for AD and PD. So from point A, I just go over a distance of AD and go up a distance of PD. And then that'll give me my coordinates for point P. So now what we need to figure out how to do is figure out, okay, how long is AC and how long is BC? Well, if we look, BC is this side right here. And if we know the coordinates of point C, I can just do the difference of the Y value. So this Y value minus this Y value, and that'll give me the length of that side. All right, so now what we need to do is figure out the coordinates of this point C, so that can help us find our lengths. So just like before, I know the X coordinate of this point did not move or did not change coming from point B, so it just went straight down. So this X coordinate stays. And then from point A to move over to the right means that I didn't move up at all, so my Y coordinate doesn't change. So that stays as Y1. Now when it comes to the distance from B to C, that's just the difference of Y values. So I'm gonna just say Y2 minus Y1. All right, and if that's unclear to you, let's just say this point had a Y coordinate of 8 and this point had a Y coordinate of 1. You can kind of see that the difference is 7. If I go from 1 to 8, that's 7, or just 8 minus 1. And then the same thing with the X values. I know that this distance right here is going to be the difference of X values, which is X2 minus X1. So I can use X2 minus X1 to replace AC, and then I can use Y2 minus Y1 to replace BC in my expressions that I came up with. All right, so now that I know the distances, then all I got to do to finish it off is to go, okay, from this point, point A, how do I get to the x coordinate of my point P? Well, I take whatever x1 was and I add that distance AD to my x coordinate, which is x1. And then when I go up, I start with my current y coordinate, which is at point A. My y coordinate is y1, and then I'm gonna add that distance PD to whatever that y coordinate was. Those two right there are gonna give me the coordinates of point P. All right, so now the coordinates of point P. Again, if I start at x1 for my x coordinate, if I start at x1 and I go over a distance of AD, that'll put me at the x coordinate for point P. So I'm gonna start off at x1 and then I'm gonna add the distance of AD. Well, what did I say AD was? It was that ratio A over A plus B of that horizontal distance x2 minus x1. And if you think about it, A over A plus B is the fraction that AD is, and that's just a fraction of AC, which is x2 minus x1, so that makes sense. That's the x coordinate. Now for the y coordinate, it's the same concept. I'm starting at the y coordinate of point A, and I'm just going up a distance of PD. And we said PD was, again, that same ratio, A over A plus B, times, this time, the vertical distance, y2 minus y1. Just so that you're clear, this right here is the x coordinate of my point, and then this right here is the y coordinate of my point P. So it does look like a lot of variables, and so as long as you understand what each variable represents, it's not that bad. So you know your line segment is going to be from points A to B, and so x1, y1 is just the coordinates of point A. And then x2, y2 are the coordinates for point B. And then your ratio is A to B. And so that's pretty much it. It's not a bad thing to use the formula so long as you know why the formula is the way it is. Because a lot of people, if you just give them a formula, they're not going to know how to use it or what it means. So you can use the formula, at least just know what it means. And hopefully I did that in this video. So thanks for watching. Hopefully you liked it and hopefully it made sense. If it did, make sure you leave me a thumbs up. If you have any questions or any suggestions that you want to see in the future, just make sure you drop a comment. Make sure you hit that subscribe button if you're new. And with that being said, I'm out.